Hello everyone, and today I bring you a new exercise on LeetCode. Kth largest element in an array. We have an array and we want to return the kth largest element. Oh, I just can sort the array and then return the kth element. But we have a clause out here saying, can you solve it without sorting? And that's what we're gonna do today. In order to do that, we have to introduce a new data structure, Min-Heap. What does a Min-Heap do? It's a priority queue. We're going to store the minimum value always on top. Then if we peek or pop, well, in this case pull, because I'm using Java, we get the minimum value. And we do this for k values. Like our size is gonna be of k values. I'm just gonna demonstrate an example on how this works because you're gonna understand it right away. We have our array. We put the number 3. 3 goes, let's say here. The number 2 goes above 3 because it's smaller. Then we get the number 1. But now, how many values do we have? We have 1, 2, and 3. But k is equal to. We remove the last element. Pop. Now, we add 5. But 5 is greater than 3. Let me just remove this. We're just gonna put the 2 here, the 3 here, and the 5 here. Because we want the 2 on the top of our queue. Oh, but this is size 3. So we have to remove the smallest element. Now we add 6, and we repeat the process. And then we add 4. And we remove it again. Boom. So now our kth value is gonna be the element on the top of our queue. That's it. We're here in Java and we're just gonna write our code. First of all, we have to create a queue. And we're just gonna keep it in natural order. It's gonna put the smallest element always on top, and that's exactly what we want. So now we're just gonna fill in all the numbers, and each time we have the size greater than k, because we just want to keep the kth largest elements in our queue, we basically remove the smallest element. For int nums, we are going to eq.add num, and then we are just going to do a if statement. If eq.size is gonna be greater than k, and we just pull eq.pull, remove the smallest element, and then that's it. And then we return eq.peek. Pull will return the element, the smallest element, or the element on top of our queue in case we just decided to use another order. And it will return, but remove the element on top of our queue. While if we just do peek, we're just gonna return the element and we're not gonna remove it. Let's see if I run this, it's correct. Seems correct. Let's see if I submit it. Yay! There's probably a better way to do it, but we got pretty good time. So to conclude this video, let's talk about time complexity. If we just sort our array of nums and we return the kth largest element, we get a time complexity of n log n. Why that? Because we have n values, and we're going to just sort the array. This is not optimal. There's a better way to do this. Let's check in our min-heap approach what's the time complexity. Every time we insert an element in our min-heap, it takes log of n, which n is the size of our min-heap. But we explicitly keep our min-heap of size of k. So in this case, each insert is going to be log of k. Then we iterate this process of adding a value to our min-heap n times. With the min-heap is more efficient because we have n log k, where k is going to be always less than n, and for array very, very large, this is more optimal.